Alright, let's finish up acid-base balance. And we can move on to the reproductive chapter. So, some disorders of this acid-base balance, we're looking at metabolic acid-base disorders. So obviously we have an excessive loss or production of fixed or organic acids, and so this carbonic acid bicarbonate system is going to work very, very hard to try to balance this metabolic acid-base disorder. And so respiratory acid-base disorders are going to be imbalance of CO2, either generation or elimination that's taking place. And so this is going to try to be corrected by the depth and rate of your respiration, either slowing it down or increasing your respiration. So if you have increased amounts of CO2 in your system, or your partial pressure of your PCO2 goes up, you're going to have increased respirations with increased removal of CO2. And that's why it's really nice to have your respiratory system working normally so that this process can take place. So if we're looking at metabolic acidosis, develops when you have a large number of those hydrogen ions released by those organic or fixed acids. And this is, again, accommodated by your respiratory and renal responses. So if your respiratory system is malfunctioning, you have lung disease, then your renal will definitely take over. So your respiratory response to acidosis is going to be increased respiratory rate, which lowers your PCO2. So you have your hydrogen ions that are going to combine with your bicarbonate to form carbonic acid, which will then dissociate into H2O and CO2, which can then be exhaled. So you have increase in respiratory rate to get rid of the the water and the CO2. Your renal response is going to be that the water plus the CO2 is going to dissociate into the carbonic acid, which then dissociates into the hydrogen ions plus the bicarbonate, and you can have the hydrogen ions secreted in the urine, and then the bicarbonate will be reabsorbed back into this extracellular fluid as a buffer. So if we look at this image, so we have an increased amount of hydrogen ions that go into the system. So here's your hydrogen ion coming in. It's going to combine with the bicarbonate, which will then form that carbonic acid, and you will have it exhaled. So you'll increase your respiratory rate to get rid of the CO2 and the water. You can have other buffer systems that can absorb the hydrogen ions. So we saw the protein buffering system, the amino acids, the hemoglobin, and then the kidneys. You're going to have you're going to secrete hydrogen ions, and you're going to reabsorb the bicarbonate to replenish your bicarbonate reserves. So that will go up into your bicarbonate reserves here. So if we look at the activity of the renal tubules in CO2 removal and retention or production of bicarbonate, so this is your tubular fluid, this is your extracellular fluid. So the CO2 that is going to be generated by the tubular cells is added to the CO2 that's coming from your extracellular fluid. So this is from your tubular fluid, your extracellular fluid going into those renal tubule cells. Again, you're going to have the dissociation that's going to take place. So the association forming carbonic acid, which is going to dissociate into the hydrogen ions and the bicarbonate. So then the hydrogen ions are actually pumped out into the tubular fluid to be released with the urine. And then the bicarbonate will go back into your extracellular fluid in exchange for chloride, and sodium will come out with the bicarbonate, and that's going to provide, go into your buffer reserves and provide into your bicarbonate reserves, and so they will both be available for buffering. Then if we look at metabolic alkalosis, so when you have large numbers of the hydrogen ions are removed from the body fluids, so we look at the rate of kidney hydrogen secretion declines. Tubular cells do not reclaim that bicarbonate, and then because we want to hold on to the hydrogen ions, we want to get rid of the bicarbonate because we want to decrease our pH, not increase it. And then we know that the collecting systems are going to transport that bicarbonate into the urine and retain the hydrochloric acid in your extracellular fluid, trying to make your body more acidic. So, alkalosis is accommodated by your respiratory and renal responses. Again, the respiratory response is decreasing your respiratory rate. So this is your water and CO2, so it's going to hold on to the water and CO2, which will become carbonic acid, which will be converted to hydrogen ions and bicarbonate. So these extra hydrogen ions in circulation will decrease the pH, making it more acidic. Your renal response, again, proximal convoluted tubule, distal convoluted tubules, and collecting system. Again, the H2O and the CO2 will be held on to. So the HCO3 is going to be secreted into the urine in exchange for chloride. You're going to have the hydrogen ions actively reabsorbed into the extracellular fluid. So if we look at the image of that, you can see that it's holding on to the carbon dioxide going back into the system. So here we have release of hydrogen ions from other buffering systems, either the proteins or the hemoglobin. Will release those hydrogen ions into the blood. We know that the kidneys are going to generate the hydrogen ion that are going to go into the system combined with that bicarbonate, and it's going to cause the bicarbonate is going to go into the bicarbonate reserve, and these hydrogen ions are going to decrease the pH, taking you to a more acidic state. At the kidney level, so the CO2 generated by the tubular cells and from the extracellular fluid are going to come into the renal tubules again, dissociate into carbonic acid. Then we're going to lose the bicarbonate, and we're going to retain the hydrogen ions and the chloride. So ions are going to go back into the extracellular fluid, hopefully causing it to become more acidic. So respiratory acidosis. So obviously CO2 generation outpaces the CO2 elimination by the lungs. So it's going to kind of shift that bicarbonate buffer system towards generating more carbonic acid. So the water and CO2 are going to go towards the carbonic acid, producing more hydrogen ions and bicarbonate, increasing the amount of hydrogen ions going into the system. So we're going to have to neutralize those hydrogen ions, and we're going to use the buffer systems within the body. So we're going to try to increase our respiratory rate to get rid of those extra hydrogen ions. We're going to secrete the hydrogen ions, and we're going to hold on to the bicarbonate, and then hopefully some of the proteins within our body will bind some of those free hydrogen ions into circulation. So again, this is what takes place, and you end up with respiratory acidosis. So we're not getting rid of enough CO2, so it's going to shift, and we're going to end up with the bicarbonate going into the reserves. We're going to have lots of hydrogen ions that are going to be in place, so we need to have some changes take place to get rid of this problem. So this is homeostasis. So we have hypoventilation, so we have increased PCO2. So elevated PCO2 results in a fall in plasma pH, because we know that they inversely related. So elevated partial pressure of carbon dioxide leads to drop in pH. So responses to acidosis. So you're going to try to stimulate arterial and central cerebral spinal fluid to increase the respiration rate. We're going to try to get rid of the hydrogen ions at the kidneys, hold on to the bicarbonate, and then other buffer systems are going to try to accept some of those hydrogen ions, hopefully decreasing the partial pressure of CO2. We're going to have decreased hydrogen ions and increased bicarbonate, returning the blood back to a normal pH. So alkalosis, we have CO2 that's being eliminated too quickly, and so we're not generating enough CO2 and we're eliminating too fast. So it's going to shift towards the left, so it's going to form more carbonic acid. So this is your hydrogen ion plus your bicarbonate. It's going to go towards production of carbonic acid, which then can dissociate into H2O and CO2. So those hydrogen ions are going to be removed and put back into circulation as the CO2 is exhaled and water is formed. So we're losing too many hydrogen ions as we exhale. So the buffer system responses to this are we're going to decrease our respiration rate. We don't want to lose any more hydrogen ions, so we're going to decrease our respiration rate. The kidneys are going to hold on to the hydrogen ions, and the bicarbonate will be secreted, and then the proteins and hemoglobin are going to release that free hydrogen back into the circulation. So again, this is the events that take place. So we're releasing too many CO2s in water, so we're losing hydrogen ions. So it's coming out of the reserves, combining with the bicarbonate to form carbonic acid, and we're losing too much. So this is homeostasis. So hyperventilation would cause decreased PCO2, and we'd have respiratory alkalosis. So we're going to slow down our breathing. We're going to hold on to the hydrogen ions, get rid of our bicarbonate, and then the other buffer systems are going to release hydrogen ions, hopefully have an increase in hydrogen ions within our system, decrease bicarbonate, returning us back to homeostasis. And that's all that I have for this chapter on electrolyte, fluid electrolyte, and acid-base balance.